parents strategies to score in PSLE science. All right. Okay, my name is Yang Iskandar. I'm the principal tutor for EduFront Learning Center. Okay. An overview of today's presentation. First, I'm going to give you an overview of the primary science curriculum. Okay, why you should be concerned. All right, as parents. I'm going to show you the themes in primary science, meaning basically the syllabus, what is expected of the students at PSLE, the assessment objectives. Okay, when they take PSLE, what are the kind of questions that will be asked in the PSLE. And then I'm going to share with parents secrets to success in primary science. Okay, using the CPA model. It is a model crafted by me, actually starting new, and it's not really a secret. Okay, but through my experience as a teacher, okay, since I started teaching in 2003, I've taught many graduating classes, many P6 students. So over the years, I've acquired a lot of experience in guiding my students in taking the PSLE science. Okay, so I'm going to share with you what are some of the success factors. Okay, I have many students who have scored A-star, A, and have gone to good schools, not only for science and other subjects as well. Okay, and the third point I'm going to focus on is how busy parents can help their children in PSLE science at home. All right, I know parents are very busy. Okay, you have other commitments. Many parents tell me, well, they cannot help in science at all. It's very different. Okay, it's very common. Okay, but I'm going to share with you what are some of the things that we can do. I think all parents can do. Okay, so and then in the end, I'm going to share with, and I'm going to open the session for a question and answer in the last 20 minutes. Okay, hopefully I can keep to the time because I've got a lot of things to share with you. Okay. All right, a brief biodata about myself. I graduated from NUS with bachelor's and master's degree in 2001, and then I joined NIE. I trained to be a teacher. All right, I got a diploma in postgraduate diploma in education, and then I started my teaching career in Maristella High School, the primary section. All right, where I taught mainly primary 5 and primary 6. Again, my first P6 class that I took was 2 years after I started in Maristella, which is a P6 class, and they did quite well. It was the second best class, but the student from my class got the top in PSLE in that year for that school. I think if I'm not wrong, he got 273 for his PSLE. All right, and then in 2005, I was promoted in the same school as head of department for ICT, information technology, where I helped the various departments, the maths department, science department, English, mother tongue department, on how to infuse the use of technology in their various subject matters. Okay, and then I left MOE and I worked in the Middle East as a university lecturer. Right, and then in 2011, I returned home and I joined back MOE as an adjunct teacher. And in 2012, I started with a group of friends, Concept Learning and EduFront Learning Center. All right, so right now, myself and we have a group of tutors who are teaching in our centers. Okay, that's a brief biodata about myself. All right, now coming back to the topic itself, why you should be concerned. Okay, number one, primary science curriculum is very different from our time. All right, in the past, it used to be a lot of memory work. You memorize what is being taught in school, and then during exam, you just have to repeat or regurgitate whatever is being taught. All right. Right now is the shift towards 21st century competencies, towards critical and inventive thinking, towards the use of information technology, communication skills. And the curriculum has become very, very challenging and very, very competitive. All right. And why parents, I believe, as parents, we should get involved in our children's education. Number one, we need to, okay, they really need the support from us. Okay, and if we know what is going on in the curriculum, then it is a high chance that it will be respected by our own children. Okay, because it's not easy, taking PSLE and going through the education system nowadays. All right, and then also there are wide choices of resources available for parents, whether learning centers, books, session books. Okay, so as parents, as intelligent parents, we have to be aware of the various resources available, and we must have the skills to evaluate these resources, okay, such that we can give the right resources to our children. Okay, because We do not want to waste money and energy and time to purchase the wrong kind of resources and and no results in the end. And also, every child is unique, and every child has different learning needs and abilities. Okay, so as if we are, are aware of what's going on in school, the syllabus, when we're able to coach our own children, so that is the very best. It is very best for our own children. Okay. Okay. So far, everyone can hear me. Yeah. Any problems at all so far? Okay. So I have a few more parents who just joined in. I have 10 attendees now. Okay. Okay. All so far, any problems? Can hear? Huh? Okay, very good. Thank you so much, Mr. Abu Bakar. All right. Okay, so primary science framework. What you're seeing now is the primary science framework. Right in the middle is science as an inquiry. Okay, if you notice here, okay, if you observe here, at the bottom here, student as the inquirer, teacher as the leader of inquiry. Okay, unlike the past, where teacher disseminate knowledge and information. Okay, right now, information is all on the internet. Okay, you have Google. Alright, where in many times my students know a lot of things much more than myself and the teachers. Any kind of information they want to know, you just do a Google. Okay, so the shift, MOE has shifted. Okay, the trust of science. Alright, rather than just memorizing the concepts. Okay, and writing down the concepts, it is about inquiry. Okay, about understanding and being able to apply the concepts. Skills and processes. Are they able to conduct a fair test? Are they able to conduct a scientific investigation? Okay, and ethics and attitudes in the learning of science. Okay, and a lot of focus on science in daily life, science in society, as well as science and the environment. Okay. All right. What you can see here, there are three main sections. Okay, in the primary science curriculum. Okay, number one, knowledge, understanding, and application. Okay, our students, they need to know scientific phenomenon, facts, concepts, and principles. They need to know scientific vocabulary, terminologies, and convention. Be able to use scientific instruments like thermometers, the new ones are data loggers. Okay, and the technical and the safety aspect, scientific and technological applications. All right, the one in the middle is, I think, is the most important for our students. Okay, which is the skills and processes, okay, in doing science. All right, skills like observing. There are 14 skills and processes, or commonly called as process skills. All right, these are the basic ones. Okay, observing, comparing, classifying, the use of apparatus and equipment, communicating, inferring, formulating hypotheses, predicting, analyzing, generating possibilities, and evaluating. All right, and processes, being able to creatively solve problems. And be able to make decisions and investigation. Okay, scientific investigation. All right. On the right side here is not so much important in terms for exam wise. Okay, but it is in general the learning of science. Okay, they want to inculcate curiosity, creativity, integrity, objectivity, open-mindedness, perseverance, and responsibility. Okay. All right. Now, overview of the themes in primary science. Okay, the primary science curriculum is divided into 5 big themes or big ideas. All right, diversity, systems, interactions, cycles, and energy. Okay, now diversity is what is an environment made up of. Okay, for example, we have living things and non-living things. How is it important to maintain diversity? Okay, how do we go about understanding the diverse range of living things and non-living things? Okay, we have bacteria, fungi, animals, plants living together. All right, and then the second theme is systems. How are the different parts of a system? How do parts of a system or different systems interact together to form a function? Okay, interaction. How does man interact with the surroundings? Okay, what are the consequences of man's interaction with the surrounding? Okay, cycles. What are the cycles in our everyday life? How are cycles important to life? All right, and fifth, energy. How does energy affects man and his surrounding, and why is it important to conserve energy? Okay, and under each of these big themes, okay, there are several topics. All right, and these topics form the topics in your children's textbook. All right, in diversity, mainly they learn in primary 3. Okay, they learn about living things and non-living things. Okay, diversity of living things and diversity of materials. Alright, how materials, the different properties of the various materials. Okay, and in systems, in primary 3, they learn about the plant system, okay, human system, the muscular, skeletal, okay, the digestive system. Alright, in primary 5, under the theme of system, they learn about systems in living things. Alright, in humans, which is circulatory system and respiratory system, and for plants, about the plant transportation system, okay, about the xylem and phloem, okay, and cells, the cell system, okay, they learn about the cell parts, the difference between the animal cells and plant cells, and then electrical system. Okay, this is P5, one of the big topics in primary science. Okay, and interactions, they learn at primary 3, or sometimes they learn at primary 4. Okay, it depends. Some schools they categorize lower block and upper block, and they may swap topics between P3 to P4. Alright, so means most schools they learn Magnus in primary 3. Alright, at primary 6, interactions, they are learning forces, environment, webs of life, adaptation, and man's impact on the environment. Okay, under cycles, the theme of cycle at P4, they learn about matter, about the 3 states of matter, okay, solid, liquid, and gases, the cycles in life, the life cycle, and P5, they learn about water cycle, okay, reproduction in plants, reproduction in humans. Okay, for the theme of energy, in P4, they learn light energy and heat energy. Right, in P6, they learn about photosynthesis, energy conversion, right, the different types and forms of energy. Okay, so this is to give you the overview of the topics that they are learning. Okay, from primary 5 to primary 3 to primary 6. Okay, by the way, PSLE, there is an okay, all the topics are tested from primary 3 to primary 6. Okay, so at P6 itself, you can see that these are the major topics itself that teachers are right now they have to complete by June. Okay, so it is quite a big topic itself. Okay, and you will find that in many classes or many schools, teachers may not have the time to go through the topics with the students learn in the earlier years, like P3, P4, and P5 topics. So that's why I always tell my students and parents to always continue to revise, right? Like this heat and light topic, for example, they have learned in primary 4, but it always comes out, okay, in the PSLE, in the exams, and the questions are much more challenging than when they did heat and light in primary 4. Okay, likewise for electricity, they learn in primary 5. Okay, again, primary 6 is a very big topic, which many of them have forgotten. Okay, it's not an easy topic to master. Water also, about condensation, evaporation, melting, about the water cycle is a very big topic, again, which they have to, other than learning the P6 topics, they have simultaneously to learn the P5 topics, the earlier topics as well. Okay. Okay, coming to examination format. Okay, in the science exam, unlike the maths exam they have 2 separate papers and there's a break in between. But for science, it is one paper straight, 1 hour 45 minutes. But it is divided into 2 booklets, booklet A and booklet B. Okay, booklet A is a multiple choice questions, 30 questions, and every question 2 marks. So MCQ itself carries 60 marks, okay, of the entire exam, okay, which is a B. If they get full marks, they can get a B. Okay, the open-ended question is usually the problematic question for many students, okay, because they're not able to answer, okay, according to the requirement of the questions. Okay, so they can be, one question can be 2, 3, or 4 marks question, and it's worth 40%. Now, I would like to emphasize about time management. Okay, in PSLE science, the paper is 1 hour 45 minutes, okay, which is 105 minutes, right? And it is 100 marks. So I always tell my students that you have about 1 minute for every 1 mark question. Okay, meaning that if they are doing MCQ, for example, MCQ is, each question is 2 marks, so they should take a maximum of 2 minutes. Okay, in fact, they have to take about 1.5 minutes for each MCQ question. If they are taking more than 1.5 minutes, so it means that they would be, they might not have time to check, and and if the open-ended question generally take longer time, okay, than the MCQ question, right? So they have to take note about the time management. Okay, this one that you may want to emphasize. Okay, by the way, science questions in PSLE it needs a lot of thinking, and for every MCQ, it usually is about 1 page. Okay, so the kind of thinking that they have to do, even in MCQ question, is quite a lot of processing that they need to do. Okay, so it's very challenging for our students. Okay, now assessment objectives. Now I want to emphasize that unlike our previous time, we just memorize the facts and then write. Okay, but now it's no more that way already. Okay, the 40% is not only knowledge but knowledge with understanding. Meaning, this is where they test the concepts. All right, it carries 40% of the entire paper. Okay, 60% is about application of the knowledge and process skills. Okay, number one, they need to be able to apply the scientific facts, concepts, and principles to new situations. Okay, not old situation, not the situation that they can see in the textbook, but in totally new situation. Later, I'll show you some PSLE examples. And B, be able to use one or more of the combination of process skills, okay, which I've shown you earlier, okay, from the syllabus. Alright, now this is the CPA model. Not to worry too much about CPA model. This is the term that I coined for concept mastery. Number two, process. P stands for process skills mastery. A stands for answering technique mastery. Okay, this is my own. I came up with this model. Alright, for students to be successful in primary science, number one, they have to master the concepts. Okay, in the past, if we master the concept, it's fine. Okay, we can score in PSLE in the exams. Alright, but right now, for current syllabus, okay, you still need to master the concepts, but that is just forming the foundation of PSLE science. Okay, the next part that our student needs to master, which is the most important, I would say, it will be process skills. Okay, mastery of process skills. Later, I'll show you examples of what I mean by process skills. Okay, that is easier for us to understand. And the last part here is answering technique. Okay, many parents tell me, oh, my child do not know how to answer correctly. Okay, the reason they are not able to answer correctly, number one, because they have forgotten the concepts. Okay, or they do not have a firm understanding of the concepts. Number two, and this is most of the time the case, which is they are not able to apply, okay, using the process skills. Okay, the process skill that they have is not developed yet. Alright, so if you don't have this, automatically the answering technique will be way off. Okay, but if your child has mastered concepts, okay, are very good in process skills, I would say answering technique would not be an issue. Just like maybe a few strategy here and there, but this is not a major thing. Main thing is the concepts and the process skills. Okay, now mastering scientific concepts, right? What do I mean by scientific concepts? Okay, example number one. These are just some examples of scientific concepts. Okay, another topic of heat, for example, the children needs to know, okay, that heat flows from a body of higher temperature to a body of lower temperature. Okay, that is a concept. All right, living things. Okay, living thing needs food, water, food, and air to survive. Okay, that's another concept. In condensation, they need to know that condensation is the change of state of water from gaseous to liquid state. All right, and in light, light travels in a straight line, or light can be reflected. Okay, magnets, like poles repel and unlike poles attract. All right, these are some examples of scientific concept. Okay, now how to inculcate the scientific concept? Now, in schools, what they learn in schools is that through experiments. All right, the students, the teacher teach scientific concepts through the use of experiment. The teacher take them to the science lab. All right, make them do experiments on heat, on light, and magnets. And then from there, the teacher will introduce them the scientific concept, or the student will discover themselves the scientific concepts, okay, through the use of experiments. But I know some schools, some students did tell me that, oh, they rarely go to the science lab, so that's one of the things that maybe you may want to assist and get your child in that. All right. Okay. So science concepts, actually, we can inculcate, or we can infuse in our children on a daily life basis. Okay, for example, in a coffee shop, right? The change of state of water. Okay, if say we buy a can of Coca-Cola, okay, it's just freshly off the refrigerator. Then we can ask our child, how come there are water droplets around the outer part of the can of the Coca-Cola? All right, so here then we can have the opportunity to talk to them about condensation. All right, at the park or at the beach, we can talk about plant reproduction. Okay, how the seeds are dispersed. You see the coconut fruit. Okay, how it is dispersed, about adaptation, about environment. Okay, how the different organism adapts to the environment. Okay, when we are ironing clothes, we can talk about heat transfer. Okay, how the heat is transferred from the hot iron, okay, to the clothes. Okay, and we can talk about conductors of heat. Okay, how the plate of the iron must be a good conductor of heat, and the handle of the iron is insulator of heat. Right? When we are in the car driving, right, we can tell our students, our children about the conversion of energy. Okay, how the chemical potential energy in the car or in the fuel is converted, okay, into kinetic energy, okay, and so on, and about frictional force also, how frictional force is exerted when the car is moving, between, say, the frictional force between the tires and the road. Okay, so science concepts can be infused in our daily life. Science is everywhere. All right. So rather than when we take them for holiday or go anywhere, we can take the opportunity to to talk to them about science concepts. Okay. Yeah. So actually, I have some activity for for you. Okay. There are probably I'll take about 2-3 minutes. Okay. All right. Okay. These are some of the daily life that we experience in the kitchen, having dinner, traveling in the bus or in the car, picnic at the park, family trip to Universal Studio, watching television at the swimming pool on a holiday. Okay, if any parents here, if we can take a look at any of the any of the situation here, maybe you can give examples of how you can talk about scientific concepts with your children. Anyone here? Okay, if you're ready, you can just type in your you can type here. Okay, Madam Nazima, you are typing something. Okay, very good. Thank you so much for participating. Okay, while waiting for Madam Nazima, maybe I give you some ideas. The rest, please, if you have the opportunity, okay, in the kitchen, we can talk about changing the state of water. Very good. Okay, all right. Can you give me specific examples? How can we talk about the changes in the state of water in the kitchen? Okay, freezing. Okay, very good. Probably if we freeze water, put it in the freezer. Okay, we can talk to our children how the change of state. Okay, from liquid state to solid state, water to ice. Okay, Madam Lenny, Ryan is very curious about what he can learn in USS. Very good. Very good question. Okay, Universal Studio, you have the what do you call it? The roller coaster, right? So in roller coaster, Ryan is in P5. In P6, you learn about this energy changes. Okay, so they learn about gravitational potential energy. How the roller coaster right at the top of the the rail. Okay, how the gravitational potential energy is converted into kinetic energy. Okay, as the roller coaster goes down, is going down, right? So you can actually talk about conversion energy in USS. Okay, Madam Yatima in the kitchen talk about good and bad conductors of heat. Okay, very good. For example, pan, okay, frying pan. The pan itself, it must be a good conductor of heat, right? So that you can cook the food fast. Okay, but the handle must be a insulator of heat, right? Because if not, you may not be able to hold the pot or the pan. Okay, traveling in MRT. Okay, very good. How mist is formed on the spectacle frames. Okay, very good. Example. Okay. I think it's very good that you are using the right word, which is mist. Okay, many students, okay, like in the kitchen, let's say boiling water, right? When you boil water, you can see many students say, oh, the white smoke or the white, actually the right word to use is mist. Okay, the white thing that we see, that's actually called a mist. It is formed because of condensation, and those are actually made out of tiny water droplets. Okay, many students will have the misconception, they think it is steam. Okay, steam is actually, you cannot see steam actually. Alright, what we see, the white color clouds, it's actually called mist. Okay, so this is a very common misconception. Alright, another thing about water vapor. Okay, many students think that water vapor is actually liquid state, but water vapor is actually in the gaseous state. Okay, so there are quite a lot of misconception here. Alright, so thank you very much, Madam Lenny, Madam Yatima, and Madam Dasima for participating. Okay, I shall move on with my presentation. Okay, how to get the students to remember scientific concepts? Okay, I always get the students to use mind maps. Okay, in consolidating the scientific concepts. All right, because it's quite a lot of topics that they need to know from P3 to P6, and many students, they forget. Okay, that's very simple. They forget. All right, like just the PAN CA1 paper exam. Okay, I've looked through of some of their papers, and then they say, oh, they have forgotten what they have learned in magnets, which is in primary 3, and then in heat in primary 4. All right. So the thing is that the challenge is how to get our students by PSLE or by the final exams, the promos, the preliminary exam. They must be able to remember and recall and all the scientific concepts from P3 to P6. And remember, it's not only science; they have to remember other subjects as well. Okay, so they have to start now. If your children is at P6, they have to start doing the easiest way. Okay, is I believe is by doing a concept map. All right, or sometimes we call it mind map. All right, so this is an example done by one of my students on the topic of cells. Okay, so you see she insert a lot of colors. All right, cell division, unit of life. All right, unicellular, yeast. This is another example here on the topic of water. Okay, it is so okay, the thing about mind map is that the concept map, it is not about the final output. Okay, it's not really about the final output. It is actually about the process of doing the mind map itself. Okay, many students tell me, oh teacher, I got a headache, I cannot do mind map, it's very difficult. Yeah, it's true. Okay, it's true that got a lot of headache, because imagine for 20 pages of information of the textbook, they need to summarize in one page itself. Okay, so that is the challenge itself. So give your children time, okay, to let them construct their own mind map. Okay, and remember, it's not the final output. Okay, it is the process of doing the mind map that is what we want. Because if you go to Popular, you can actually buy books which compiles mind map. Okay, I've seen at least one book that has mind map. Okay, so there's no point. You just give to your children and then get them to memorize. It's no point. Okay, but the process of doing is very important. Okay, but of course you need to monitor, make sure that they have included all the points. Okay, in their mind map itself. And also when they are doing mind map, it is not just one mind map. Oh, that's a perfect mind map, right? It is a process that they can repeat. Okay, until they are satisfied with their mind map. Okay, so when they insert colors, graphics, so they're able to remember and recall the facts better. Okay. Okay. Next, this is a very important. So please stay focused. All right, about science process skills. Okay, now coming back to I showed you earlier slides here. So science process skills, these are the 14 process skills that the students need to know for PSLE science. Alright, so I've actually copy and paste from the science syllabus itself, the latest science syllabus. Okay, for example, interaction with environment. Okay, a student must be able to observe, collect, and record information regarding the interacting factors within an environment. Okay, you see the underlined word, observe, collect, and record. Alright, there are another topic on forces, must be able to investigate the effect of friction on the motion of objects and communicate the findings. So it's not merely stating what is friction, okay, what are the various types of friction or what are the things to reduce friction, but rather to investigate and communicate the findings. Okay, next, to investigate the effects of forces. Okay, not just stating the type of forces, but be able to investigate and communicate the findings. Okay, about electrical system, be able to construct simple circuit and investigate the effects of some variables on the current in the circuit and to communicate the findings. Okay, so you see the words here, this is directly off the syllabus, alright? Okay, now I have actually compiled, came up with my own the kinds of process skills question that that usually comes out in the exam. Okay, I would say probably 80 to 90% of the exam question can be classified under either one of these four categories. Okay, number one, I'll show you later on what I mean by these categories. Number one, experiment investigation. Okay, number two, question involving graphs and data analysis. Okay, number three, question involving comparing and observing. And number four, application questions. All right. Okay. Now this is an experiment investigation question. Okay, where students are given a setup, either one setup or two setup or more. Okay. So in this question, it